In this video, let's take a look at a free response question from 2015 on the AP Calc BC exam, and we're going to be taking a look at number 6 together. So we're going to consider the curve given by the particular equation of y cubed minus xy is equal to 2. And we're also told that it can be shown that this dy dx, or y prime, or the derivative, is going to be y over this 3y squared minus x. So we have our original equation, and we also already know what the derivative of it is. Alright, let's go ahead and start with part A, which is going to be finding the equation of a tangent line to the curve at the specific point of this -1, +1. To find out the equation of this tangent line, we need a point and a slope. We already have the point here of -1, +1, and we have the instantaneous rate of change, or the slope, over here, but this is just the general form for any point along the curve, so let's go ahead and specifically find the slope at this particular point at -1, +1. So if we go ahead and take our derivative, and evaluate it at a particular point of x, y, which in this case, it's going to be this -1, +1. So we can go ahead and plug that in. We're going to say this is going to be -1, +1. We can go ahead and find the instantaneous rate of change, or the slope at that particular point. So let's go ahead and plug in this x and y into this expression right over here. Alright, once we substitute in, let's go ahead and just clean this up a little bit. In the numerator, we're still going to have this 1 on top. In the denominator, this 1 squared is going to be 1. 1 times 3, that's going to be 3. And then we're going to take away -1 or just add 1. So we can say that this is going to be equal to 1/4. So the instantaneous rate of change, or the slope at this particular point, is going to be 1/4. Alright, so here we have a point, and here we have a slope. So let's go ahead and use both of those pieces of information to write the equation of the tangent line in point-slope form. So remember, our point-slope form formula is this equation right over here. And if we go ahead and plug in our point and our slope, it's going to look something like this. So this equation right here would be the equation of a tangent line that goes through this point of -1, +1 to this original curve that we had from the start. Now let's take a look at part B, where we're going to find all the coordinates of the points on the curve at which the lines tangent to the curve at these points are going to be vertical. Alright, so in order to do this part, we're going to have to figure out where the tangent lines are going to be vertical or have a slope that is undefined. Now remember, we were given this information from the beginning that this is the derivative of the original equation, which means that this tells us the instantaneous rate of change. Now, if we're going to be finding out vertical lines or vertical tangent lines, that means that the slope is going to be undefined, right? Because all vertical lines have a slope that is undefined. So when is that going to happen? That specifically is going to happen when the denominator over here is going to be equal to 0. So if we can find out when the denominator of this derivative is equal to 0, that's going to be where the slope is undefined. So let's go ahead and take this denominator of 3y squared minus x and set it equal to 0. Then let's go ahead and just add x to both sides. If we go ahead and add x to both sides, we can see that x is going to be equal to 3y squared. Now, if you're wondering why we're isolating x instead of isolating y here, keep in mind that when we're talking about vertical lines are always going to be set up in that form of x equals a number. So if we can find x equals a specific number, that's where a vertical line is going to be. So if we can figure out what the value of this right side of this equation is equal to, then we can figure out where that vertical line is going to be located at that specific x value. So let's see if we can figure this out. Let's look back at our original equation, which is this equation right here. And let's see if we can manipulate it real quick so that we just have one variables of y's here, so we can figure out what this y is equal to. So we're basically just kind of setting up a system here. So let's substitute in 3y squared in for x. And if we do so, we're going to get this equation right here. Next, if we go ahead and multiply these two together, we can go ahead and write our equation as this, and then we can go ahead and combine these like terms of 1y cubed minus 3y cubed and say that -2y cubed is equal to 2. If we go ahead and divide both sides by -2, we're going to get that y cubed is equal to -1. And if we go ahead and take the cube root of both sides of this equation, we're going to get y is equal to -1. There's only going to be one cube root since we have an odd number of negatives. So we just found out the y value at which that vertical tangent line is going to occur. So let's go ahead and substitute that into this equation over here, which will tell us the equation of that vertical tangent line. Plugging that in, we're going to get this x is equal to 3 multiplied by this -1 squared. And then if we go ahead and square -1, that's +1, so then x is going to equal +3. That's the equation of that vertical tangent line. And so if you take a look at this original equation, or this curve here, basically what we just found out is that we are going to have a vertical tangent line at this x equals 3. That would be the equation of the tangent line, but where are the coordinates at which it's going to hit the curve? It's going to be at this 3, -1. So here's the y coordinate at which it intercepts, and this is going to be the x coordinate as well. And then the vertical line equation that is tangent is just this x equals 3. And so there's only one set of coordinates here. It's going to be at 3, -1. And if you want to see this real quick on a graph, you can see the black curve is going to be the original equation. This point of 3, -1 is going to be that point of tangency, which we just figured out. And then that vertical line of x equals 3 is that vertical tangent line that is going to hit the point at 3, -1, or hit the curve at 3, -1. All right, let's take a look at part C. What do we have to do here? In part C, we have to go ahead and evaluate the second derivative at the point on the curve where x equals -1 and y equals +1. Alright, so if we want to go ahead and find out the second derivative here, let's go ahead and use the first derivative that we already were told. And so remember, this was our first derivative, so let's go ahead and use that to figure out part C, or the second derivative at that specific point we're given. Alright, so let's go ahead and find that second derivative at this specific point. So if we go ahead and take this second derivative at a particular point, and in this case our point is going to be at this -1, +1, so those are the values we're going to be plugging in. We're going to need to go ahead and apply the quotient rule here. So notice that we have a quotient, we have a numerator of this y, and we have this denominator of this 3y squared minus x. So to start, I'm just going to take this denominator function and then multiply it by the derivative of the numerator function. So I'm going to go ahead and keep this in parentheses and say it's going to be 3y to the second power minus x. And let's go ahead and multiply this quantity by the derivative of y. Now the derivative for y is just going to be dy dx, but for now I'm just going to go ahead and write y prime just to keep it nice and simple, but keep in mind that's dy dx. Next, let's go ahead and find the difference of this product with another product. In this case though, we're going to be multiplying this numerator of y by the derivative of that denominator function. So let's go ahead and multiply this y by the derivative of the bottom, and the derivative of the bottom, we're going to go ahead and use the power rule here a couple times. So the first part is going to be 6y multiplied by what? I think it's going to be multiplied by y prime. Don't forget we have that y in that term, so we need that dy dx. And we have to go ahead and subtract what? The derivative of just -x is just going to be -1. So that's going to be the second part here of our numerator. After we write that difference in the numerator, don't forget that we're going to have this denominator function squared. So let's go ahead and take this 3y to the second power minus x. Let's just take this whole quantity and raise it to the second power. Alright, so now that we found the derivative, let's go ahead and take this x and this y value of -1 and +1 and literally just substitute it into each of these locations where we see x and y. Now, as for these y primes or these dy dx's, we can also just plug in that x and y value of -1 and +1 into this dy dx expression over here to find out the value of those y primes. So I'm actually going to go ahead and do that first. Let's go ahead and take this -1 and +1 and substitute that into this to find out what that y prime is going to be. And so you can see here that y prime is going to be 1/4 when x is -1 and y is +1. Alright, so now that we know that these y primes are equal to 1/4, let's go ahead and plug in our -1 and +1 into each of these other locations where we see x and y. And I believe if you substitute those values in, you should get this. Alright, now just looking at this part over here, I think if we go ahead and square the 1, that's going to be 1. 1 times 3 is going to be 3. 3 minus a -1 is just going to be 3 plus 1, which is going to be 4. And we go ahead and take that 4 and multiply it by 1/4, that's just going to equal 1. Now for the second part of our numerator, let's go ahead and follow the order of operations. 6 times 1 is going to be 6. 6 times 1/4 is going to be 6/4, or 3/2. 3/2, or 1 1/2, take away 1 is just going to be a half. and a half multiplied by 1 is just going to be a half. So I think we're going to have 1 minus a half, and that's going to be our numerator, and this is going to be on top of, let's see, we have 1 squared, which is 1, times 3 is 3. 3 minus a negative 1 is 3 plus 1 is 4, and then 4 squared is going to be 16. So I think this whole thing is going to be on top of 16. Now on the numerator, 1 minus a half here is just going to be a half. If you take a half and divide it into 16 pieces, then that's just going to be 1 over 32. Alright, so the value of the second derivative when x is negative 1 and y is positive 1 is going to be 1 over 32. Alright, so that just about wraps up this example of a free response question from the Calc AB exam, specifically dealing with some implicit differentiation. If you found the video helpful, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep with the great work that you're already doing.